Okay, the next session that we are going to go through, we have about 6 pages, quite tough 6 pages to go. So everyone is here, right? Right? I'm the only one. I'm not the only one, right? Okay. At least we have 5 people, including me. Hope everyone's here. Okay. We in the lecture, in the beginning of this lecture, I told you that there are 2 ways to access to the row of data frame. One is just using this merged data frame and blah, blah, blah. You can put values, something like this, no problem. It doesn't cause any trouble. However, sometimes it can cause a warning. Why? Because Python sometimes asks you to explicitly tell which row you want to use. So how can it do that? We can use method called LOC. That's that is basically location. Exactly same. These two are exactly same. However, what it does, what this one is more explicit way saying that where to put the value. So in the merged DF data frame, find the location, but what is this colon? Means everything. Sometimes you can put something like this, 0 to 5, or something like this. However, in this case, I just want to find the entire row and then find the column and then put these values in the location. This is more explicit way and be more safer way, so to speak. But there are another way is ILOC, which is I location, index location. So let's see what's the difference between those two. Okay, first we have budget DF. Let's see just ahead. Right? I don't think I like this one. Merged DF seems a better one. We have merged DF, right? We have all the value. What's the index? This is the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. That's the index. Just in case, before I make any strange or stupid mistake, I'm going to copy this to T. So now we have T, which is exactly the same with the merged DF. In this case, if we want to access to the country here in index 2, 3, 4, we can use ILOC 2 to 5. It's weird, right? I just said I want to access to 2 between 2 and 4, but I said 2 and 5. It's weird. But how it works in Python is because it excludes the last value. That's how C++, C and everything was developed in the beginning. So it includes the first index 2, but exclude the last index 5. So it goes from 2 until 4. I don't understand why this is how it looks like. So if you want to get the value, if you want to get those a list of 10, you can just say 0 to 10. Then you can have country from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because the index is number as well as it's the same number read, the number is basically a each index, numerical index, and each how do I say, index name is basically the same at the moment. Those are basically index numbers, right? So you can use location as well. It doesn't need to be index, but it can be location. However, we can make this a little different. I mean, you don't need to follow up all of this. I'm just explaining you what's the difference, okay? We can set index as country code. But in place true. Now, if we see T, now country code became an index. There is no column called country code. to access the value of, let's say, Australia here, arrow location, arrows, AUS. Now we can use index name to access the value, right? However, if we say 0 to 10 with arrow C, it says it's type error because now index name is different from the index number, but we can still access to the value using IROC, which is index location. Basically using its implicit index number, which is started from 0 until the last value. This is how you can access to the value in data frame. So if you understand more deeply, you may want to have a look at this review. So what's the difference? ROC is basically to access using the label or the name of each row. IROC, you use IROC when you want to access to the value using each index number. That's the difference. And yeah, you can't just choose one. You always need to use both. Depends on what you want to do. So in this case, because if we want to access to the countries, then like this case, target country. In this case, we need to set equals target country and etc. etc. However, the other way, if target country name or 3-digit was index, you can simply pop clean ROC. See, it's much shorter compared to the above line, right? If you set the index correctly, things can be much easier. However, when you want to set the index name, you need to be careful to be aligned across all data frames or data sets. Otherwise, it can be a little tricky to use. Otherwise, you can't really get much benefit, right? So it doesn't need to be exactly same for across all, but across similar data types, it needs to be, if it's the same, much easier to access. Okay, that's what I wanted to do. And then to make sure that you guys actually understand what happened so far, I want to have a small exercise. It doesn't need to be your country, but choose whatever the country you like. All you need to do is actually changing the target country, but it's your time to review the process slowly one by one, and then fill these rows. I will make 5 more rows here. Please fill the value. Not going to use this because this will take too much time. But we already done population and GDP, right? Let's try to have greenhouse gas emissions or CO2 as well for any selected country. Just choose one country, whatever you like, except your own country, because otherwise everyone will choose the same country. Choose somewhere else and then fill the value. Okay, unit is megaton CO2. Each person will choose just one row. Okay, everyone, I will leave this table as is, and then please fill the table before the next week. This is sort of kind of review process that to actually know that you can apply this Python functions and method in a correct way. So if you find any struggling or if you find difficulties in filling this table, please let me know. To just send me an email, pop an email anytime, please. And then we will go to the next step. And then we'll finish today's course. So next step is going to be, by the way, do we have any questions so far? Nope, all good. Okay, I will go to the next step. So far, we have the total amount, right? I don't know if these numbers are correct or not, but we have numbers like Philippines. Which Philippines is Hamad? We have numbers all different numbers by country, right? Assuming that all the calculation was correct, you can see, obviously you can see each country have totally different values by different standard or allocation method, right? Another question that we need to ask is how to make the pathway. We know the amount, but how to make the pathway from now until 20 until 2000, 2100 or 2050 or something like that. So we will need the data, of course. We will have the data. We will use Australia as a sample example country because that's the easiest one and which I built already. And then we will go through to create very simple linear pathway from now until the emission becomes zero. Okay, this is very basic triangular calculation. It's not difficult at all, but please bear with me. I don't need to import pandas or numpy, but just in case, let's assume that we are doing all of this again from the beginning. We will import pandas and import numpy. I'm pretty sure I explained to you before. Pandas is a data frame and numpy is numerical library module that basically almost always whenever you start Python, you need to import those two libraries almost always. And then target country is AUS. And then we will get just value of AUS from merged df by merged df country code is target country. And then we'll see how it looks like. We have values here. Bit confusing, but the other way that we can see is okay, just get the first value. As we said, we are going to get just the first row. Now it becomes a bit more clear. It becomes a row became a series. So it was horizontal, but now it's been more vertical way of structuring. So it looks clearer now. This is how we get the country value. Now we need to extract CO2, this value from the country, which we did before, right? So emission, we are going to get the current emission first. We've been doing similar quite often. Float, now I'm going to get it as float and CO2 and divide by? No, I think it will be, let me double check it. CO2 is 373. I think this must be the megaton rather than a kiloton. And then allocation is, again, float, row. Gonna use allocated budget, which we calculated above, but this is gigaton, so we are going to turn this into a megaton CO2. Correct. Now we have current emission and then allocation. From a very fast look, we can see about maybe Australia will have about 10 years to remove its entire emissions if they don't reduce their emissions at all, and if they just use fossil fuels as much they use now, right? That's the thing that we can get it. Now we are going to use this value to calculate how much year we have. So allocation, I'm not sure if we have it here. No, unfortunately. So allocation is the area of a triangle, right? And the current emission current is the y-axis. What we need to find is the x-axis, right? So y equal ax plus y equal no a area equals 0.5 multiplied by x multiplied by y. That's the equation we are going to use. The start year is 2024, right? And then years until 0. When the year becomes 0 is this. How did I get it? So basically, years until 0 multiplied by emission current divided by 2 equals allocation, right? If we send emissions current to the right side and then 2 to the right side, then it became this. Now we can calculate emissions until 0, right? This is we have. And then if we print out years until 0 is from 2024, Australia has 19.5 years. As if they follow linear decreasing trend, they have 19.5 years to use up their remaining carbon budget, which is 2045, 44, or something like that. Based on this analysis, Australia needs to reach net zero by 2045, which is very unlikely. I'm gonna remove some part of this so that you can see easily and to follow what I just did. Let me just make it a little clear. Okay, this is what you need to do for the next 2 minutes. And if you don't follow or understand, please let me know. For Paolo, sorry that you can't do it on your own computer. I'm not sure if you can do this on mobile, which can be pretty tough, but do it in your imagination. It always helps. As a modeler, sometimes it's not joke. Sometimes I do coding while dreaming. It's very stressful, but sometimes it happens. Particularly when I had a big trouble with a code, some bug or error, which I couldn't really finish by like 2 or 3 a.m. When I back to sleep in my dream, I do the coding, and then out of sudden, I found a solution. I need to get up as soon as possible. I need to write it down somewhere, or I need to code it right away. Always, very interestingly, it always work 100%. But in the morning, when I see my code, I have no idea how it solved the problem, but it worked. Yeah, you need to you can ask this to any modelers or any coders, programmers. They all have this such a strange experience. But now this fun part is getting away because we are using AI. Okay, how is it going? All good? I will wait just one more person. Okay, thank you, Amanda and Yano. And then Okay, it said that South Australia will how do I say, will decarbonize by within 19.53 something years or something like that. But this is not the best some sort of number in terms of policy suggestions. You can't say you need to decarbonize the entire country by 2045.4 years or something like that. So we need to round it up. Year zero. When is the year zero? There will be many different ways, but we can go something like this. Start here -1 plus int. So integer. Make it as an integer rather than from float to remove decimal point until year zero. If we do it, I said I didn't use start, but start here. And then year zero is 2043 is the year where Australia needed to decarbonize. And then we want to make a straight line from now until 2043. So we need to create the list of years first. We are going to use MP and create array as a range, as a list of using range function from when start, which is start here, -1. The reason that we need to -1 is because our value is from 2023 and our current is actually 2023, right? Our calculation starts from 2024, but the current value is 2023. So we need to start from 2023 and until when? Year zero, which is 2043, but +1. Why? Always the last value is ignored, it's not included. And then data type should be integer. And then we will print out years. Yep, range. Now we have value from array, which include years from 2023 until 2043. Now we need emission value. Emissions should be linear space, emission current to 0 using total years. Okay, let me explain you. Linear space is a function that create a linear value between 2 points, right? Basically interpolate. And then start value, the start value, y value, y1 is emission current and y2 is 0. So the value should start from the current emission level to 0 during the length of years. Length of years is this, the number of those all values, right? And then we will print out emissions. It looks about correct. It started from 373.6164, which is the current CO2, and became 0, right? We are going to create a data frame. TD data frame is one way make a data frame. And then first column is going to year, and then each value, this is a bit confusing, so I'm going to put it in the line below. Year is years, right? And comma. Next, emissions is emissions. Right? And then we can print data frame. Ta-da! We have emissions from 2023 until 2043. Just one more thing that I want to do is print it out or make it as chart. We need to make it as chart. We can use a method called plot quite easily, just simple as is. However, if you just run it, you have two lines. Why? Because we have two columns here, right? So we need to set index as year. Index becomes x-axis, right? And value becomes y-axis. And then if we run it, we have a straight line from 2023 until 2043 of this emission reduction pathway that Australia need to follow if they want to achieve 1.5 degree with 50% of chance. Okay, that's what we want to achieve today. So I think I gave you some time to do this part. So no, sorry, this part. So let's go through the next part together until the plot. Just in case, I'll make it a little smaller so that you can see the entire. Maybe I can just remove the output. Right. Basically, this is it. This is what I wanted to cover today, and there is just one thing that I'm going to ask. Please fill the table while you have time before next week. Please fill the table, and next week we are going to discuss a little about the table result and see what kind of trouble that we have. And then I will tell you a little more about how to use Cursor AI and how to use library. I mean, there is a module, carbon budget module that Planet developed a couple of months ago, which can do most of this job quite easily, but in a bit more complex way. So we will talk about that next week, and then we'll wrap up. So while we are waiting the next week, please do this process, do these two cells, and then let me know if you have any questions. And if you are all okay, you can just say goodbye.